Good morning, everybody. It's time for us to get started. I want to welcome you again to our the NCAT from Research to Implementation webinar series. I'm really excited today about this thick lift asphalt paving, um, innovation that's been done out there. There's a few folks that have been using it. We're excited that we've got Utah with us today to talk about that. South Carolina has done a bunch of work with it as well, and they did some work here with NCAT. So our speakers today are going to be Howard Anderson, Dave Johnson, and Luke Peterson. So Howard Anderson, he is the state asphalt engineer for UDOT. He graduated from the University of Nevada, Reno, with both his master's and his bachelor's in civil engineering. His master's thesis studied the asphalt materials and polymer modified binders, including laboratory and field work under John Epps. Howard started at UDOT in 1989 as the state bituminous engineer. Was instrumental in getting hydrated lime as an anti-strip into their specifications there. And he's worked with high mod, high density asphalt mix for UDOT. He also serves as a co-chair for the Rocky Mountain User Producer Group. Sitting with him today is Dave Johnson from the Asphalt Institute. He's one of the regional engineers that covers the Rocky Mountain area there. Dave got his bachelor's and master's at Montana State University. He's got over 30 years of experience working with pavements. He did spend 5 years as an adjunct professor teaching pavements there at Montana State University as well. Spent 6.5 years working with Bureau of Indian Affairs, and he's been with Asphalt Institute for about 16 years now as a regional engineer. Maintains his Montana license. He's a member of TRB, double APT, and is an officer with the International Society for Intelligent Construction. He wanted me to mention that he's been married to his wonderful wife, Kathleen, for 34 years, and they have 4 children, 8 grandchildren. And he didn't put on there, but he is an avid outdoorsman and loves to hunt and does a lot of that kind of stuff. Our other guest we have today is Luke Peterson. He started with Ingevity Corporation as their technical marketing manager. Works in a big chunk of Canada, also covers Utah, Montana, and Nevada. The main product that he's promoting is Evotherm in those regions. Before working in Ingevity, he worked for Staker Parsons Materials and Construction, which is a CRH company from 2009 to 2002. Luke worked as our quality control department, where he's involved in the production of 1 million tons of asphalt annually. And that Beck Street plant is huge. I got to visit him there. It is a big plant, a major operation there. Luke's a member of the Utah Asphalt Paving Association Technical Committee. When he's not working, he enjoys his time with his wife and his kids. And he also makes custom leather patch ball caps. Is that right, Luke? Right? I've seen those out there. So another little thing that he's got. So as we kind of jump into things here, this kind of rapid rebuild or this thick lift paving stuff, there's several things to kind of think about here. Minimal lift thickness typically is 3 to 4 times whatever our coarse aggregate nominal maximum aggregate size is. And forever and ever we were told if we go thicker than, too much thicker than that, we're not going to get density. If the thought was if we go more than 5 times that nominal maximum aggregate size, we'll struggle. So paving thick, kind of what we define as paving thick there is anything that significantly exceeds that 5 times the nominal maximum aggregate size. So for example, if we put a 5-inch lift in of a 1/2 inch nominal maximum aggregate size mix, that's a ratio of 10. So that would definitely be what we would call a thick lift paving. So back in 2018, there were 3 sections that were built on the NCAT test track with ratios as high as 16. And really what we were doing there, South Carolina, DOT had come to NCAT and they wanted to look at this technology and look at the ability to do thick lift paving. Could they get the density they needed? Could they get the smoothness they needed? And we did some different things between diamond grinding and thin lift overlays with them, put those sections together. And really through that work found that there were really no big issues with the placement or compaction, and definitely not the performance, because they lasted long enough that they continued traffic into the 21 cycle. So as we look at what was done out there, we had 6 to 8 inches that were placed as a single lift on top of a crushed aggregate base. There was a deep mill and fine mill at intersections for to simulate what was going on. They used the South Carolina B mix is what we used at the NCAT test track here, and we used the local aggregates for that. We did some trials off the track, certainly trying to see what we could come up with up in the parking lot area. If you've been to the track, to make sure that we were able to get the density and so forth that we needed. So then a couple of things that were explored were the diamond grinding to make sure we got this new smoothness and some thin lift overlays. So we absolutely wanted to put out there that when this was first done, we had a tremendous amount of interest from the other track sponsors that were involved, and we've seen that interest continue to grow. I know that the Utah picked up on some of those types of things. They tried these types of mixes. Asphalt Institute was worked really strongly with them. They've got a ton of fantastic magazine articles out there that I read. I think Howard sent me those 3 or 4 years ago. He was sending me those articles. It was really fun to look at. If you want to kind of know what the South Carolina B mix was, here's the idea. It was a half-inch mix, that 12.5 nominal maximum aggregate size. They used a 6422 binder there with 25% wrap, and that would kind of be a half a grade bump for us here in Alabama because we have that half grade here that we use, which is a PG 67 minus 22. So there is kind of a half a step down using that virgin liquid there. There was Evotherm, the warm mix additive used in that particular mixture. They were designing to 2.5% air voids, and I think when we hear from the Utah guys, they're going to tell us that they're using a lower air voids as well. They used a gyration level of 75 on their mixture. The AC content was just shy of 6%. You can see the difference between what came from the virgin liquid there and what was part of the wrap. So here is some photographs of what was being done on section S9 on the track, which is on our south tangent there. It was full depth rapid rebuild, they called it. It was about an 8-inch lift that was put down in a single pass. Also were trials done on the north side of the track in sections 10 and 11 as practice runs. Really, they did that, but they put thin lays on top of it because they were really wanting to look at the thin lays and how those thin lays performed. But the thin lays definitely compared to smoothness, similar to the grinding that was done on the S9 section. So you can see the instrumentation has been placed there. Here's the paving operation. If you look just right to the right side of Jason Nelson's hip there, you can see how deep that milling is, that we are putting that mix down at 8 inches deep at that point. You can kind of see here as it comes across the edge where they had to mill the shoulder out to make sure that it drained when we got our rains here. You can see how thick that asphalt was placed. They did also do some things like wanting to watch the temperature. And I think we're going to hear from the folks in Utah that the temperatures are very important because we have such a huge mass of material out there that it takes a tremendous amount of time for that to cool down. So what Dr. Dave Tim did is put together this dowel that you can see on the left side with temperature probes at different levels. And then they crammed a rod down into the mix so that they could embed this temperature probe down in there and monitor the temperature at those different levels to see how the temperatures changed. And they definitely saw differences in the temperatures at the very surface and the bottom that cooled much quicker than the center of that big mass of material. And then when it came to the cores, they pulled density cores out of this to see where the density range came. And they took those cores and they cut them into thirds. So they took the core longitudinally, cut them into thirds. So we had a top third, a middle third, and a bottom third. And that's what we see here in this graph. So we can see where those densities came in on the different sections that were done. And we can see that we were pretty good, in my opinion. The only one that really struggled at all was N11. The bottom was it was about 91 and a half or so in there, but everything else, they were getting densities that were 92 and above, even almost to 96%, even on the bottom. So what we've had as this rule of thumb all these years is you can't get density on the thick lifts. It's kind of been shown that that's not necessarily the case, and it is something that we can do. So given that little overview of some of the things that South Carolina so graciously sponsored to be done on the NCAT test track, I want to turn the time over to Howard and Dave, and they can tell us about Utah's experience.
All right, Travis, thank you. I'll let Howard take off.
Okay, welcome everyone. Back in 2021, we put a test section down at our Wendover port of entry, And we're going to be tag teaming this between Dave and myself. Dave was there with me when this went down. And let's just go to the next slide.
All right, so as Howard said, this is the port of entry. We're looking into the state of Nevada from Utah at this particular location. And as you can see, this was June of 21, so just a little over 3 years ago. We'll see some of the data coming up in a moment, but we're going to ignore the stuff on the left because Travis just gave a nice summary of it. We want to focus in on the Utah. And this was not the first work that Utah did. Back in the mid-teens, they started doing some work in the lab, and then as we can see in 2015 and 2016, they put down a couple of different sections on some secondary highways utilizing a 7634 binder. That was just a simple drop-in, but Utah very heavily relies upon the Hamburg, and this is a 12.5 millimeter mix, and they did samples all the way up to 6.8%, and Howard has a nice slide on that, and they really tortured this material, as we'll see, going all the way out to 40,000 passes and a few other things that Howard will talk about. And the bottom line is, no matter what they did in terms of combinations of mixtures with this, none of them after 40,000 passes were failing the 10 millimeter criteria that Utah has for their Hamburg.
Okay, very, very quickly, for our PG 7634 binder specification that we have, we spell out the G-star separately at a 1.3. We have the phase angle separately at a maximum of 70. We have an elastic recovery, a minimum of 90. Our high mods are around 98, 99. With that, we do cut the sample immediately, so our numbers are about 5% higher than what you would expect without cutting it within 2 seconds. And then we have our delta TC in there. So it's a fairly standard specification. This, if you were doing MSCR, this would relate to a 64E34 that Montana is looking at doing for their test section. So when you look at our AC grading system of the past, we were basically doubling the absolute viscosity from one grade to the next, a 5 to a 10 to a 20. So when the Sharp grading system came along, they attempted to do the same thing, and a PG 58 to a 64 is similar to an AC 10 to an AC 20. So even though these numbers in the PG system are only going up 6 degrees increments, they are doing the similar thing, and they're doubling the viscosity. So the point to keep in mind is when you go from a 64 to a 70, your G star is essentially doubling. And then when you go from the 70 to a 76, it's doubling again. So our regular HMA has done it at PG 64-34 with our design, our super pave design. When we go from the 64 to the 76, we now have a modulus, a G star 4 times that. So if you go back to the Asheville road test in the late 50s, early 60s, our design parameters that utilize 4% air voids were based on neat binders, unmodified binders, uncrushed aggregates, rollers and equipment that are not near as good as we have today. So things have changed. And so the point is, with the binders that we have, the crushed aggregates that we have, we can change the rules and lower our voids. So when we first looked at this, we ran Hamburg tests at the 50 degrees Celsius. We upped the binder contents. We couldn't get the materials to fail. So you see the duct tape on there. It's kind of funny. I like this slide. We added 20 extra pounds. You see the number is 177.5. So we took the 158 up to 178 with 20 extra pounds and ran the Hamburgs on that. What you see here is the bottom of the Hamburg samples where the wheel was passing over. We cut those out separately and ran density tests on them so we could see how much that material continued to compact during the Hamburg testing up to 40,000 passes with additional weight. Okay, here's the slide that really tells the story. If you're looking on the y-axis, the numbers are either in millimeters of rut or they're in air voids. So that if you go to the middle bar, that's the air voids of the average of the two slabs to begin with. And you can see that we started out hitting the 7%, and then as we put more material in there and up the binder content, the voids went down. So the left group that we have here, this is the super pave design that was done at 4.8% asphalt content. And we have the first slab here and the first slab here that was run, easily passing. And then we added the 20 extra pounds and ran another test on it under the water at 50 degrees Celsius still, and easily passed. This little blue line that you see right here and right here, that's the densities from those little pieces that were cut out from under the wheel, to see that even as these densities came down, we were still stable. And notice that we arbitrarily added 1% and 2% extra asphalt, which is unheard of, right? We're over asphalting this material, but it's really not sensitive to that, at least in the ranges that we are showing. So it basically changes the game. And here's just some of that data that's there for your information.
So jumping out to Wendover, the district engineer in Salt Lake, who will offer credit to at the end, Lonnie, he was not convinced. He was actually fairly sure that this was not going to perform in the fashion that it has. And so he chose a location that he deemed the worst possible scenario within his district in Utah, which took us to that port of entry. And you can see that while the ADT is not very high, over half the traffic stream is trucks. Therefore, you wind up with between 2 and 2.5 million easels per year. So based on easels, this is a pretty good traffic location. Add to that this is a very hot summer location with temperatures easily exceeding 100 degrees multiple days throughout the summer. And just for comparison's sake, if you were doing a 98% reliability using the standard software, you'd find that this location is looking for a 6428. So we're moving in both directions outside of the normal 98% reliability. So very widespread. The specific to this particular project was a mill and inlay, milling out 6 inches of existing PCC. So in essence, they were building in a bathtub. It's only about 330 tons of material. It is that highly modified material, the 76 minus 34 material. It is a dense graded 12.5 millimeter mix on the very much on the fine side. And they also looking at constructing this in one lift. The question that has been raised all the way back into the early 70s in New York to today is, why do we bother with 2 passes if we can get away with one? And we'll see in this presentation that there are some concerns with a single pass. It's not a panacea. And the other thing to note is that this was a 2-hour, one-way haul from the Beck Street plant that we've mentioned out to Wendover. We'll look at a few of these things in another slide, particularly on the Hamburg. But for right now, a couple of things we want to point out is that this is a 50 gyration mix. It is a 12.5 millimeter, as mentioned. It's 100% crushed material. This is quarried material. The material had 15% wrap, and we can see the breakdown between the virgin and wrap binders. So there is some contribution from the wrap, but it's principally this highly modified material. At the 50 gyrations, it was a 1% air void. When you take that out to the normal gyration level that Utah DOT utilizes, it's essentially a 0 air void mix. The VMA requirement was bumped by Howard for this particular operation, and Luke Peterson, who we're going to hear from, his design came in at 15.3% and 93.3% on the VMA and VFA respectively. They did a drain down test because there was concern with this being such a rich mix that they might have some issues with that. That portion of the specification is actually going away now, and because they haven't had any issues with that. And then they also ran a 40,000 Hamburg on this. And in this case, you can see that instead of adding extra weight, they simulated the weight with temperature, and they went from 50 to 54 degrees C on the second 20 passes. And even after 40,000 passes, it was just a little over 6 millimeters. Those slabs were targeted to 4% design instead of the normal 7% that you would see. And we'll talk about some performance testing that we did at the Asphalt Institute, and we'll get back to that air void content with these mixes as well. The other thing to note is that they have moved away from 40,000 passes, and they're only doing 20,000 now at the higher temperature of 54 degrees C. Looking at some specimens that came out of Luke's lab when he was still with Staker, these are just sitting on the table. As you can see, it looks like a fine graded mix that's on the rich side. Nothing outstanding in terms of the pucks. They don't look that much different. Howard?
Okay, thank you, Dave. So one of the questions that has come up, if you go really dense, do you have enough room for the asphalt to simply expand within the mix if the temperature goes up? And so that's easy to check. And so you have your standard volume tables in ASTM that show how much the asphalt will change from, and I chose to look at it from 25 Celsius up to 60 Celsius. And basically, when you go through the numbers and let that binder swell from those two temperatures, and if you start with a 13% effective binder volume, it only swells to 0.29 more. And so at the most, just a few tenths. And so if your in-place voids are 1% or more, you have plenty of room for the asphalt to swell based on temperature.
Well, and I said we had another slide, and I have to apologize or move through this slide more quickly because I did cover a bit of this on that last slide. But what we really wanted to highlight is the fact that this mixture did not display any trouble in passing the Hamburg test. And as an example, here are the graphs that produced that data that we just saw, the first 20,000 graphs, and then I shifted the second one to try to match them up. And you can see that it's a very linear graph. We are not seeing a stripping inflection point of any sort. We're just simply, quite frankly, rolling along under the Hamburg. And I would say that the mix is kind of sleeping because it's not doing much, which is extremely good. Stager Parsons have a great deal of concern and caution about putting this stuff down in a single lift with no experience doing so. And so Luke and his crew at the time decided that it would be best to put down a test strip. And so the day before we went out to Wendover, they produced some mix and laid it down at their facility with minimal preparation. As we mentioned before, the Wendover project is inside of Portland cement concrete on all three sides. As we can see here, it's on gravel without any side support. There is no hull. We're right at the hot plant. And so they were producing at about 300 degrees F. And that material is showing up then very close to that temperature. And they were utilizing standard construction equipment and methodology. And so just a typical double vibratory Ham roller. You can see that this mix is showing a significant amount of stability. I have to apologize, unfortunately, I didn't get a picture of when the roller was off to the side, but it was extremely stable. We did not see this mix walking out under that vibratory roller, even when the roller operator had it hanging over around 6 inches.
So you want to mention it started out at 7.5 inches.
Oh, very good. Yes, it was, with that, your typical 25% roll down, when you're shooting for 6 inches of compacted thickness, that meant that it was coming out behind the screed at about 7.5 inches. Great point, Howard. The one issue, whoops, go the right way. The one issue that they ran into and they learned from in this test strip, as you may imagine, the volume of material running through that paver is higher than you normally see. And so they were struggling to get enough material through the paver, into the paver, to get it through the paver at the test strip. Temperatures were very good. You can see the surface is about 275, and since it was produced at 300 with no hull, not surprisingly, we're pretty darn close to that temperature in the midst of the mat. And so some great lessons were learned. First of all, density was easily achieved. It was just 5 passes for breakdown with that Ham roller that we were seeing. There was no intermediate roller. They simply finished with that same roller when it was all said and done. The feeding of that large volume was achieved, but they had to make some alterations to their process to get that. Very important to note that the stability of this mix was exceptional. Even with 7.5 inches of uncompacted mix coming out behind the screed, that heavy vibratory roller was not walking out like you might expect with a mixture that did not have side support. So no real significant issues were encountered, which took us out to Wendover the next morning. As was mentioned already by Travis, this mix takes a long time to cool down, and we'll see a graph on that. And I bring that up because there was some concern. The mix in that test strip was still rather warm that next morning. And so it did display some of the behavior that you might expect from a warm binder laden mix at this stage. And so there was some concern that maybe we shouldn't run out to Wendover yet and give this a little bit more time to cool off and show its ultimate stability. The decision was made not to do that with Howard's leadership. And so we were out to Wendover. This again is looking in Nevada. Here's on the other side, the post scale. I have to point out, as a tack coat guy, I'm not real pleased with the tack coat, but that gets mentioned every time. And my friends at Staker are probably sick and tired of me mentioning that.
Look how thick the ribbon is.
Yeah, and we've got a very thick ribbon. And the windrow itself, look at this. The shuttle buggy is barely wide enough to pick up this material. Notice how it's flowing out to the side gates on the feed of the Weiler shuttle buggy. And the mix was filling up the hopper. They did a much better job of keeping this material fed properly from the lessons that they learned. As you would expect with a 2-hour one-way haul, there was a bit of drop in temperature of about 25 degrees. Same roller equipment that we had saw before. They had the 2 rollers out there. One was essentially there for backup. The Staker Parsons crew was very cognizant of not wanting anything to go awry. And in fact, they did have an issue with one of the shuttle buggies that was a downstream result of a truck that ran into a tire problem. And so they wound up having to bring a secondary shuttle buggy that they had on site into the stream, which worked out very well. Here is that cooling curve. Luke put a probe at the bottom of this material, so just a single probe. You can still go out there today, and the last time I checked, it was still functioning just fine. And this material takes a long time to cool off. Just like Travis had mentioned, when you have 6 inches of compacted material, that's a lot of mass. And the Pave Cool or multi-cool software was employed to simulate this, and I can tell you that it tracked very, very closely to the actual results that we saw with the in-place temperature probe. Densities were very easy to achieve. We really like to focus in on this top half. Utah is a PWL state, and Howard and his team were holding Staker to the top half. So they took these cores, cut them in half, and then measured the density both top and bottom, and very consistent at the top. We have a little bit of inconsistency with the lowest density at this just under 93%. These 2 here are in the rough area where we had that issue with the truck, so there was a bit of delay, and as you might expect, that has a negative effect on density. But at the surface, they maintain a very high quality density, very consistent density. We then have a post-construction picture 5 months later. I was out there in October of last year, and this material is showing no distress whatsoever. I really like to point out there's a lot of traffic. This is the off-ramp going back to I-80, and the truck queue stretched from, here's the scale, all the way back to I-80. You could not put another truck in there without them resting and waiting on the shoulder to enter the scale. So gobs of traffic. What have we learned? Well, we learned that highly modified asphalt can be successfully constructed in a thick lift, even with a 2-hour haul. Very high densities were achieved, and as we'll see with some of the other projects that have been done at different thicknesses, that has been very consistent throughout the state of Utah. To date, there's over 4 million, probably approaching 5 million trucks that have now been over this in the last 3 years. There's no discernible movement, no cracking, zero distress. As you go ahead, Howard.
I would add to that, go back to the picture with all the trucks, that you can see the material is not bleeding. Some people felt that the material would bleed, but actually the high binder content wears off of the surface. It has worn off the surface, and it's looking like a regular asphalt surface out there with regular friction numbers.
Excellent point. And because that was one of the concerns. We have a fine mix with a lot of asphalt. The question was raised, what about friction? Well, at the port of entry with very slow and stopped vehicles, that's really not an issue. But we want to use this on mainline. And so they went out there with the British pendulum, and as you can see, skid is not an issue. Howard?
Okay, cost considerations. This was a small project, 330 tons. We expected the cost to be high. We expected, because it's an experimental feature, for the cost to be high, 150 a ton. We were thrilled with that, actually, and the costs have significantly dropped from that number. The second bullet there, we compare to SMA, which the state of Utah uses SMA as the workhorse mix on our interstates and state routes. We understand that the SMA, because it's a gap graded gradation, is going to be more expensive than the high mod, being a regular dense graded mixture. The binder contents for the high mod are close to or similar to the SMA, but the binder is a little bit higher quality, actually 2 grades higher. When you go from our SMA has a 7028, the high mod is a 7634, so it goes on both ends. To 2 grades better. There's no mineral filler needed. There's no fibers to add. There's less QC and QA testing with the high mod versus the SMA. and the production can be higher when you're in a thick lift application. And we've noticed that the cost for our high polymer binder, our 7634, has dropped significantly. And we also do not require a 7% polymer content. Our specification to meet it does not require that much polymer. We also understand that it's a potential savings for our contractor. Our industry has been very excited about getting into using this material for the potential to pave something once instead of twice. They can increase their production. Savings in traffic control costs, it makes sense to put the money into the pavement itself and to try to minimize those other costs with traffic control. User costs or delay are reduced if you're having a shorter time period to produce the pavement. There's no tack coat needed. And I think this is a big one, as we understand that tack is very important to the strength of the pavement. And that pavement is even that much stronger when there's a perfect bond all the way through and everything is in one lift. And with the higher binder contents, we have a more durable pavement. So essentially, the high mod binder allows us to increase the binder content. That alone increases the durability. So it's increased the durability because of the higher binder content, and also the binder is a higher quality. And we also know that now we have a real potential to expand our paving season.
And a note on that, one of the future projects that is in contract now, and Staker Parsons happens to be the contractor that was awarded it, is going to likely have some sections that are going to be 7 inches in compacted thickness. And their discussion of them possibly getting to that this year. And because of the thicker material, they're going to take, if they do that, they're going to take advantage of the fact that they can still have a workable material at a lower temperature than what you might expect under normal circumstances. And so for those of you that are in a part of the country or part of the world where you're not concerned with late or early season paving, you can pave 12 months out of the year. If you do happen to get a cold day, you just simply wait, and 24 hours later, 48 hours later, you're back in business. That's not the case in so much of the upper reaches of the country. And a lot of our paving happens towards the end of a given paving season as we try to button things up. And being able to go thicker can be a huge tool to help expand that paving season and not have a negative effect on the density.
So maintenance of traffic, cool down time is expected to be longer if you're in a thick lift situation, unless you're in cooler weather. The edge will be thicker, so that would need to be protected for traffic. Shorter construction time may be safer for the workers and the public. Smoothness, we have one less opportunity to improve the ride, but the contractor pays attention to that, and everything's magnified when you're in a thicker situation. Mm-hmm. But if you keep the constant speed with the paver and the material being delivered to the hopper, you'll be just fine. And the other thing that we have learned is that the higher density material can be ground, and it looks like concrete when you grind it. You're not opening it to water.
And I just want to piggyback onto Howard's comments. When it comes to paver operations, this is one of the potential downfalls, negatives, if you will, with thick lift paving. The paving crew has to be on their game. Every little mistake that they make, adjustments in paver speeds, coming to a stop, not filling the augers properly, whatever else you may want to incorporate into this list. Every single one of those, the consequences will be magnified with the thicker lift. And it goes all the way back to some of the comments that Travis had about them doing diamond grinding on the test track to get smoothness. That's a direct result of little mistakes. And some of the Utah projects are approaching it from that perspective as well, that they will profile and grind as necessary, maybe with a surface lift or not on it, depending on the circumstances in the particular project. Another section that was done also by Staker Parsons the following year, there's a section of concrete that has reached the end of its life on I-15 north of Salt Lake City. If you're familiar with it, near Lagoon Amusement Park. And that was a section that was scheduled for removal and replacement, or crack and seat, excuse me, it was crack and seat. And Lonnie, the materials engineer from Salt Lake City, once again said, hey, let's look at this. This might be an option for us. And so they laid 3 inches of this material in May of 22. Again, they got great densities. As you can see, the thickness was very close to the target of 3 inches. The average binder was very close to the minimum of 6%, and the VMA again was very respectable, as you would need to, of 15.3. To date, there has been very good performance on that. We just traveled over that section yesterday, in fact, and I will point out that the production of this was coincident to Luke Peterson, our last speaker's final days with Staker Parson.
Yes, and I would add a little correction there. It was Jason Simmons, our statewide pavement design engineer.
Thank you. Yes.
Made this good call and to put it there. But continue on.
These are just some pictures of the site. You can see the beginning of it in the northbound lane, which is the only lane that received it. Excellent pavement, no distresses. It is a little over almost a year old at this stage in these pictures. So not a whole lot to see. Go ahead, Howard.
Okay, and that's been down 2 years now, and it has since had SMA put on it. So this slide here shows the installations that occurred last year with this exact same mix, basically a 0 air void mix, 6% binder minimum content, 1% voids at 50 gyrations. And they've all compacted to very good density numbers with excellent performance. So the next one.
So I mentioned that we did some testing at the Asphalt Institute, some beam fatigue testing. I have to point out this was very limited. This material came from Granite Construction, one of the 3 contractors in Utah that have experience with this material now. And we didn't have the luxury of a full array of testing, but we do have some pretty interesting information. The graph here shows a single test with a control mixture that also came from Granite, utilizing a typical 64-34 super pave mix designed to 4% air voids and such. Comparing it to this highly modified 1% air void design. The specimens for testing were at 7% for the 64-34 and 4% air for the 76-34. And the thing that we find astounding, and I got a table next that's going to show you all of the different tests. Notice the difference between these two. You're going to find that failure on this one occurred just a little over 12,000 passes, and this is about 1.1 million passes. And so you have about a 73 times number of pass gap between these two at the same microstrain. This is the table I was talking about that came out of our lab. Your 64-34s here at top, again at 7% air voids, very close to that in the slabs that were produced. A 4% target was seen here. Notice that the microstrain levels are not exactly the same across the testing. We do have 3 that do match up perfectly at the 475 to 600 microstrains between the two. And again, notice the big shift that we're seeing in the failure between those specimens, simply with lower air void design, high asphalt content, very robust binder.
Thank you, Dave. So what we have here is some limited testing with our ideal CT. This is where Utah is going in the direction of to use that test. We see that we're getting very good numbers, typically over 400. And if you look at the far right column, that's done at 7% voids. However, this mix never sees 7% voids in the field. 7% is the target normally done because you have a installed density of maybe 93. When you have an installed density of 96 or better, it doesn't make sense to test it at 7% anymore. And so that's why our Hamburg slabs are being tested at 4%, and we're looking at ideal CT testing, moving from the 7 to the 4, although we haven't done it yet. But you can see when you do lower the voids in the ideal CT, as we've seen and heard from other folks, that the numbers do drop, but they're still very good.
And I'll just point out that neither us nor at the Asphalt Institute or UDOT have the capability of doing the Texas overlay test. And we think that just this week we found an opportunity to get some Texas overlay testing done on this, as well as a comparison to a control mix, again with the 64-34 from the same binder sourcing entity, as well as the same aggregate pit. So stay tuned. We should see some of those numbers in the future.
Okay, so what you're seeing here is one of the projects that won an award. This is the one that we talked about up by Lagoon. It's just a high level shot of it. Go ahead into the next one. This is another project that was done last year, State Route 173, and here's the bridge decks that were done. And it just gives you an idea of some of the projects. Here's a pretty good picture of 196 that was done. Excellent densities. Even though this is a thin lift, the density was over 96%. So lessons learned, density of 97% is easy to achieve. And we are seeing no rutting, and we expect no rutting based on our rut test results. Regular rolling equipment and procedures are used. There's no changes needed there. Feeding while placing such a large volume of the mix was achieved, although you have to pay attention to having the trucks there to get the material. The mix is stable and workable. There was nothing, no unusual issues at all with it. Thin lift projects are being used the most right now because that's the most work that we have going on. And bridge decks are just taking off. We have bridge decks all over our state that are being used with this. So
in 2024, Utah has really exploded, you might say, in their usage, as we're going to see in the subsequent slide, that they are now over 500,000 tons of contract that went out this year, including one project that is over 200,000 tons alone. Howard mentioned a little bit about the costs. We can see that the range is from just over $100 a ton at 103 to about $140 a ton, and that's very reflective of the haul distance. And so that's why we're seeing a notable difference depending on how close the project is to the hot plant. In District 2, where Lonnie is in 2025, 90% of their asphalt tonnage is going to be the highly modified low air void mixes, east and west, roughly in the Salt Lake City area. The most arduous advocate for additional PCC in the state of Utah is now flipping projects from PCC to this material. And as Howard has mentioned, there's been exceptional performance so far. There's been zero noted issues with any of these materials. This is just a short list of those projects. The number down here has now reached above 500,000 tons. And there is a 200,000 ton project that's in southern Utah. And then we also have some SMA projects that are changing to the high mod, such as this one on US 89 and State Route 204 to 134. And so what we're seeing is that the perhaps we could call it the older top performing surface material, SMAs, is starting to be supplanted by this material for a couple of different reasons. One, the performance has been exceptionally good with this material as we've seen so far. Two, the cost is less. And three, the contractors prefer to work with this material over the SMAs.
right, you could say it's more sustainable as far as allowing wrap, where our SMA doesn't allow wrap, and the contractors love it because they can use all of the aggregates as they crush the pile down. They don't have to have the mineral filler and the mineral fibers.
Well, and just to move through this quickly as well, this is the project at the bottom here that was scheduled for removal and replacement with PCC of an existing PCC pavement. In 2025, that is going to be rubbleized, and a total of 5.5 inches, 1.5 inches to level, and then a 4-inch surface is going to go on it. So we want to acknowledge Lonnie Merchant. We've mentioned him a couple of times. He deserves a significant amount of credit for his willingness to try this material, and in my opinion, more importantly, his recognition of the quality and the performance of this material. We keep mentioning somebody who was a big proponent for PCC. Well, now you know who that is. That's Lonnie. And he is the one who made the decision to not do the removal and replacement with the PCC that is going to get rubbleized. Clark Allen in the Central Labs has done a significant amount of work, and none of this would have been possible without the incredible partnership that exists between UDOT and the Utah Asphalt Paving Association, which is made up of the binder suppliers and contractors. I can't say enough about the quality of that. Travis, I know we have questions listed here, but I think in the spirit of time, let's get to Luke and we can take the questions at the end.
Yeah, so anybody that has questions, please type them in the chat box. I threw that up there a little bit ago, and I'll kind of divvy those out at the end. So at this point, let's turn the time over to Luke, please.
Fantastic.
Yeah, like I said, my name is Luke Peterson. I was with Staker Parson for roughly 15 years in their quality control department for several of their hot plants across the Wasatch Front and then wherever else. we had stuff going on. Yeah, so when this project came to us, we had actually bid on, adjacent to this project, we were doing an 80,000 ton SMA job. So that's really, as contractors, what we were focused on. Takes a lot of work to do that piece. And then this 300 ton of this highly modified came out of the bottom of it that we weren't really expecting. So as I started digging into the spec, started reading through it, immediately got on the phone with the DOT and with Howard and just started talking through it. Like, okay, what do you expect from this? And what does that look like? I had never, it stood outside of any design thing I'd ever learned, any criteria of any design we'd ever been a part of. So we started going through it, started understanding really what it looked like. And as we got into the lab piece of it, and it was just, and I would say the biggest thing for all the contractors out there, that if your DOTs are starting to look at this, is just be open-minded and communication with your DOTs. A lot of times I think we definitely put up walls between the contractors and the DOTs, but especially with things like this, those walls need to come down, and that we need to be talking and communicating back and forth and get help from each other. So as we got into this, I mean, it was fairly typical 12.5 millimeter, what was said. We were running 75 gyration on all of our mixes. This can drop to a 50 gyration. We're able, our normal UDOT mix allowed 25% wrap in our base courses and up through our dense grades. And then this one allowed 15%. So we were able to put 15% wrap in that. And then the biggest thing in Utah, for Utah, their air void target was a 3.5% air voids. Typically across the area, it's 4%. So we targeted a 1.5 on this. Got designing into it. At that time, there was no oil content specification. So we designed through it, actually designed it at a 5.8% oil content, took it to UDOT, and they said, well, we expect you to be at 6. So we were able to go back through, and by adding 2 more tenths of oil content to it, we dropped it, the air voids down to roughly a 1% air voids in the lab at that point, since they've wrote into their spec that has to be a minimum of 6%. So going through that, I had been a big user of Evotherm throughout my career, and I knew the benefits of that product. So I designed that product into this mix. I knew it was a 2-hour haul, so I was going to need the workability on the other end. We knew it was an extremely stiff mix. You can literally build a snowman out on the job site with this mix. Like, it will completely stand up and be that way. So I needed some extra help, and the compaction was definitely a concern. We had never done a 6-inch lift and then expect to get compaction through it. So we were able to put 0.5% Evotherm into the mix to help with the compaction, workability, and long haul from that piece. Once we got done with the design side, we went to the hot plant. We had kind of heard some horror stories of some of the other projects that have been done in Utah. And so we were able to reach out to them and start understanding what this would look like. Peak Asphalt provided the material of the 6434 for us on that. So as we got into it, we started going through it. And then once we got into it, so yeah, like I said, we wanted to do this test strip. This is the test strip section that we had just honestly graded out with a grader the morning before, and then started paving it. I'd gone to my upper management at Staker Parson and expressed my concerns of a mix that we'd never done. I knew that there was going to be more than our just paving crew sitting out on the job site for this first thing. There was starting to build quite a bit of recognition and different things. So we wanted to make sure that we were doing our best. So we ended up paving 100 tons in our yard. And this is, I mean, that's not a typical paving crew amount of people. So everyone wanted to show up and be a part of this and see what it would do. So we got going into it. Like I said, we put down about 7.5 inches, rolled it out, and then it went from there. So then it takes us back to the test strip, or actually out to the project. This was paved with double bellies, which is will run roughly 42 tons at a time in a windrow, and then needs to be picked up with a pickup machine and then placed in the paver. We ended up placing the material on the side of the project because it was so deep. We didn't run trucks in and out of the project. So we ended up putting the windrows next to the project, the paving section, and then picked it up. What did end up happening is we tried to pick up way too much windrow at first. And so we did end up plugging a shuttle buggy. For any of those that deal with shuttle buggies, they're a little temperamental. If you look at them wrong, they'll pretty much break. So you got to be careful on what you're doing there. So we had another shuttle buggy on site that we were able to bring in and continue paving. It was about 8 trucks. All the mix was loaded and paved, or loaded and sent on its way before the first truck ever got to the job site. So yeah, I mean, we paved out the whole entire, like, it's only 300 ton, roughly 100 ton on one side of the scale and 100 ton or 200 ton on the other side. Once we got done, we got the rollers on it. We were concerned of how much rolling compaction it would take, but the test strip that we were able to core and figure out what our rolling pattern needed to be, we were able to correlate gauges and do that kind of stuff. We had never had a gauge on this mix. So at that test strip really helped us for that kind of stuff, that we could have confidence in our gauges as we were getting density on the job. So like I said, it was a big thing. There was a lot of different people out there, a lot of pressure. We had paved out the test strip that night. The guy that had cored it phoned me at my house. And he said, I'm putting footprints in the job. Like, everywhere I'm walking, I'm still seeing like where I can walk. So I end up driving back out to our pit that night, looking at it, and I did not get a whole lot of sleep that night. I sat there and we kind of thought about it. I waited till 5 a.m. till when I could dare make the first phone call, and called Lonnie and Howard and got on the phone and said, hey, I think we have some real concerns. This mix does not seem like it's cooling down enough. And the original plan was to put traffic immediately back onto this pavement. So thank goodness with their calming me down and helping us talk through this, they're like, great, we'll leave it closed for roughly 24 hours so it can cool down all the way before we put traffic onto it. So we were able to talk through that. Again, it's that communication part of talking through it together. So hopefully this video will play. Sorry, it's loud. But yeah, this is the project itself. Yeah, again, a not very big project to start, but what it's done so far in the state of Utah has been huge. I'm grateful that I've been able to be a part of the first one down. There's a lot of contractors in the Utah and around that have done a lot more mix now, and they've done a great job with it. Yeah, so the part of the biggest thing is, as the contractor, is just the communication piece, especially with your paving crews, with your hot plants, making sure that stuff goes through, talking to the DOT so everyone expects what's going to be done, and going from there. Yeah, so that was my piece as a contractor, for being very nervous going into it. It's a mix that a lot of the contractors are very familiar with now and have a lot of great confidence in. And so that's what I have. Any questions?
Well, and just one piece that I'll add, Luke.
Yeah.
There's understandable concern, as Travis mentioned at the beginning in his short little presentation, with getting density when you get to some magical thickness, I'll call it. And the reality is that when you go with thicker pavements, they are exceedingly easy to get density on. And there's a couple of easily explainable reasons for that. One, with all of that room, the aggregate has a gob of room to move around. One of the things that we do in compaction is reorient aggregate. And with that thick lift, it's free to do that without it being impinged by a relatively thin ribbon. The other thing to keep in mind is that at our paving temperatures, the asphalt binder is a hydraulic fluid, and hydraulic fluids transmit energy at nearly 100% efficiency. And so you have a vibratory or an oscillatory or whatever style of roller, the energy that it's imparting into that pavement is very effectively moved through that pavement, affecting good compaction top to bottom. And so there's understandable concern about thick lifts, but in practice, those concerns don't pan out in general.
So, yeah, that was part of the effort, was to have a higher binder content to make it easy to compact the thick lift, and that's exactly what we found out.
Yep.
Yeah.
And regionally, we have the state of Montana is got a draft special provision, and they'll be doing a highly modified low air void mixture in their case with a 9.5 millimeter 3/8 mix, very close to the same specification as Utah, excuse me. Montana has moved into the massacre grading system, and so that's going to be a 64E minus 34. The state of Idaho is actively looking at their projects to find the right pilot project for themselves as well. And they're watching what's happened here in Utah as well as now Montana, and we can see some regional synergy.
Great, great. I love it. And there's a whole bunch of different DOTs that are on today that I'm hoping they can learn from this and maybe move into that realm as well. So a couple quick, takeaway things here. At least what we did on the track was that 5 to 8 inches thick. I really do like, it was fun to see how Utah's used that same mix in different applications other than just thick. But I am really excited to see those thick projects that are on the books to happen in the next year or 2 years there. I want to reiterate some takeaways that I think all three of us talked about, is that, any mistakes are magnified when we're paving that thick. If we stop the paver because we don't have trucks or whatever happens out there, anything that we do that is magnified and hurts the smoothness there. So that really does lead for that high number of haul trucks and that reliable flow of the material. And so it's every time we get to talk about that way station out to Wendover, something comes up about the truck that blew a tire, and boy, that stress that caused of the one truck that blew a tire trying to get out there. But I think that there's some important lessons that have been learned with the things that South Carolina and Utah have both done with the thick lift paving. South Carolina did this with us about 2 years ago and talked about some of their experiences. So those are folks that we can reach out to on both sides of the country, really, that are doing this same, innovative way of paving to try to take care of projects and get roads open quicker. Those density concerns that we're all concerned about them, and forever and ever and ever have said you can't pave thick because you can't get density. We're finding ways with these mixes to go ahead and get that, as long as we've got a good quality plant mix that's coming to us in a design that's been modified in the correct ways. It's not on this list here, but Luke, I really, really have to hand it to you. I love the comment that you said that if you're a contractor and you're seeing your DOT look into this, be open-minded, reach out to people, talk to people. And certainly in Luke's role now with Ingevity, I think he's going to be a resource that you could reach out to. Is that fair, Luke?
Absolutely. Yeah. Anytime we can help.
Okay.
Yeah.
So given that, if you want to see anything else on the NCAT side of what was done, the two reports that you can find on our website, which is ncat.us, from the 2018 and the 2021 cycles, are going to both have discussions on the South Carolina thick lift paving sections that were done. I'm still not seeing any questions really coming in here, but I did want to give everybody the opportunity. Here's the emails for everybody that we've had today. I know I'm offering, reach out to me if you've got questions. I think most everybody else in this group and the way that they volunteer and support the asphalt industry are probably going to be in that same boat.
Absolutely.
I always like to plug my little training program I have, Training in Your Pocket. Please look for those. We've got some new ones that have just barely pushed out. So please, take a look at those. They're great for folks that are just getting into the asphalt industry or need to know different things. There's some that are outside, some that are in the laboratory. some that are just based on volumetrics. So please check those out. Again, NCAT, we offer all sorts of training, as does Asphalt Institute. I don't have a link for you on here, Dave. I hope that's okay.
That's quite all right. They can find us.
They can,
You
yep.
know, Travis, there was one thing that I neglected to mention.
Sure.
Early on, one of the lessons learned that we had with the binder was that you need to keep the rotational viscosity requirement for that 7634 high mod binder in there to
Okay.
make sure it's pumpable.
Mhm.
And at our first project, we had issues with the binder continuing to gel and became more difficult to pump. Our suppliers figured out how to modify their formula and give us high mod binders that act like regular binders, regular polymer modified binders. So keep the rotational viscosity requirement in your specification. It's got to be pumpable. Our contractors have told us that they're going to 4-inch size pipes to pump their material. And one of the issues we had that was talked about at our last conference on this was that hauling that binder is a critical thing, and that it can be done just like regular binder, but it needs to be hauled and pumped into the contractor's tank in a timely manner to make sure that there's no issues with it.
Great. Yeah, that anytime we're working with that high mod, we really do need to work with that supplier because it's
Mhm.
a little
Yes.
bit different animal than your virgin liquids, huh?
Yes,
Absolutely.
they're pretty smart, and they figured it out. And we have 4 approved suppliers in our state now that have all figured out how to make it. So
There you go. Great, great. Okay, I'm still not seeing anything typed in here. I think that the lessons learned, you guys covered those off so fantastically that I really appreciate that. Hopefully everybody has been able to get some good information from this. I really do think that this stick lift paving is something that we really need to look at across the country, that's going to be able to help us put projects out there and get the roads open quicker for folks on these deep rebuilds. I need to plug our next webinar. Our next From Research to Implementation webinar will be on August 15th, the same time, same place. We're going to be talking about the inner layers that we can put in to reduce reflective cracking coming through our asphalt pavements. That QR code right there is live for registrations now. If you hit that, anytime you find that QR code around from this series, that same one takes you to whatever the next one is. So given that, I want to give special thanks to Howard, Dave, and Luke for joining us and letting us know about their experiences that they've had in Utah. We look forward to seeing you all the next time, and have a great day.